Hello everyone. Today we are going to discuss the part B of first internal test. These are the solution of part B, that is similarity and dissimilarity in feedback. The fifth question is briefly outline how to compute dissimilarity between students' feedback profiles described by. First part is normal attributes, that is department and elective chosen. For each chosen attribute, dij equals 0 if xi and xj are equal, and 1 if xi is not equal to xj. For multiple normal attributes, dij equals to number of mismatches divided by total number of nominal attributes. Second part is asymmetric binary attributes, that is attended workshops either is yes or no. Attended workshop yes or no, where 1 equals attended, 0 equals did not attended. Here, presence 1 is more important than absence 0. Method is Jagrad dissimilarity. For Dij equals 1 minus M11 plus M10 plus M1, where M11 both students have 1, M is M10 and M01 are mismatches. Ignore 00 because lack of attendance conveys little similarity. The third part is numeric attributes, that is CGP or attendance percentage. Method is normalized distance, that is Z score on minimum maximum. Z score's formula is Z equals to X minus nu upon sigma. Minimum and maximum is X dash equals to X minimum upon maximum minus minimum. Fourth part is term frequency vectors, that is keywords in open text feedback. Method is cosine dissimilarity. Given vectors are Vi and Vj. For similarity, cos ij equals Vi into Vj divided by Vi into Vj. Dissimilarity is Dij equals 1 minus cos ij. Moving on to sixth question. Suppose two student faculty interaction profiles are represented as tuples, that is 22, 1, 4, 10, and 20, 0, 36, 8, where attributes represent hours spent in mentoring, project reviews attended, assignment submitted, infrastructure usage count. The first part is Euclid distance. The formula for Euclid distance is square root of 2, 1, 51 and 2. The square root is under root 1033. So approximate value for Euclid distance is 32.12. Second part is Manhattan distance. The formula to calculate Manhattan distance is dm equals to 2 plus 1 plus 32 plus 2, that is 37. Third is Minosaki distance with h equals to 3. The formula is d3, that is 2 to the power 3, 1 to the power 3, 32 to the power 3 plus 2 to the power 3 under root cube. Then compute the powers according to that. The sum is 8 plus 1 plus 32768 plus 8 equals to 327858. Cube root for d3 is 327815 by 3, that is 32.01. Last part is supreme distance, that is T infinity equals to maximum of 21322, that is 32. Moving on to seventh question. The question says the median score is often a key holistic indicator of faculty or infrastructure performance when dealing with massive student feedback data sets. Purpose methods for median approximation analyze their complexity and suggest heuristic to balance accuracy and efficiency. When student feedback data sets are extremely large, computing the exact median by full sorting too slow, so sufficient approximation methods are preferred. A simple approach is random sampling, where small representative subsets of rating is drawn and its median is used as an estimator. This reduces computation to 0 k upon log k. while giving high accuracy with the sample is sufficiently large or stratified. Another scalable method is histogram or binary approximation, where the data is scanned once to build frequency counts across core ranges. The commutative counts then identify the median bin, and interpolation within that bin yields a good estimation in big O of n time, but the very small memory. More advanced systems use streamlined colentile summaries such as Greenwald-Khanna algorithm, T-digest or KLL sketches, which maintain compact data structures with probable quantile error bounds, achieving near constant space and logarithmic update time, ideal for distributed or streaming student feedback environments. Alternatively, approximate sections in distributed quick select frameworks can stop early once the median lies within a narrow candidate interval, balancing exactness and speed in practice. A good heuristic is to choose sampling or histogram methods when speed is critical and the domain example 1 to 100 is small, and to use quantile sketches when very high accuracy or integration. Moving on to the eighth question is consider student faculty similarity analysis. A sample data set of two attributes given here, like student A1 and A2. The given a new feedback query x equals to 1.4 and 1.6. The first part is rank existing students' feedback profiles by similarity using Euclid, Manhattan Supreme, and cosine similarities. First is Euclid distance. The table is given here. This is the range, that is x1 equals to s5 greater than s3 greater than s4 greater than s2. Second is Manhattan distance, that is values are given here. The ranking is s1 equals to s5 greater than s3 greater than s4 greater than by s2. Third is supremum distance. These are the values, and ranking is s1 equals to s5 greater than s3 greater than s4 greater than s2. Fourth is cosine similarity. The higher the similarity equals more similar. These are the similarities given of students, and this is the ranking, that is x1 equals s5 greater than s3 greater than s4 greater than s2. Second part is normalize each student's vector to unit length and repeat the ranking using Euclid distance. Distance computed after normalizations are given here. So ranking are S1 equals to S5, S3 greater than S3 greater than S4 greater than S2. All are similar only.